Very good evening to all the members of the course on lighter than air systems who are present in this online session. We are going to spend the next 1 hour interacting about various issues concerning this course. And also, I have a very interesting presentation to share with you. But before that, I think it will be a good idea if we can utilize this opportunity to get any queries answered. So I think Mr. Namanuddin, the teaching assistant, is already in the meeting. I would like you to please tell me, Naman, are there any questions which people have asked related to
Hello, can
the
you hear me, sir?
course? Yes, I can hear you.
Yeah, there was only one question about the final exam preparation. So that we will take in the final live session, third live session. Only one question was there.
Acha, okay, all right. So if that is the case, then I think we can straight away start. I can notice that Anamitra is in the meeting along with Naumanuddin. So, Anamitra, can you please unmute yourself?
Yes, sir.
Huh. So, do you have anything to ask or discuss?
Well, no, sir, at present. Not any doubts.
Okay, just 1 minute. Okay. So, Anamitra, I want to ask you what comes to your mind the moment you hear the word airships about safety, about any issues in the past?
Well, I personally believe that airships are actually they just are kind of one air means kind of one like air system that is considered and stereotyped to be very puny in nature, but that's actually really great. That's the belief I'm having at present.
No, no, my question is not this. My question is in the minds of general public, the moment they hear the word airships, one particular incident is always being discussed. What is that?
So the accident of Hindenburg.
Correct. So today we are going to take a very deep look at the Hindenburg air disaster. So I'm going to share my screen and I'm actually going to, okay, let me share the whole screen and then, it might be easier for me to, okay. So I hope you are able to see my screen, right?
Yes, sir.
So we are going to talk today about the Hindenburg air disaster, which took place on 6th of May 1937 at the Lakehurst Naval Air Station in New Jersey in the US. Now, if we quickly look at the history of the flight of LTA systems, we know that the whole activity started in 1783 with the flight of a hot air balloon, the world's first hot air balloon with the Montgolfier brothers. And about 100 years later, there was this airship called La France. Okay. In between, the first airship was the Giffard airship in 1852. What we can summarize in the first 100 years of LTA systems in existence is that all of them were basically very primitive and unstable balloons, which were very difficult to steer. Okay. They would generally fly along with the wind, and fighting the wind was not an easy task. And the other thing is that apart from the initial hot air balloons, the ones which were used later were all hydrogen filled, which, as you know, is a major fire hazard. Now, in 1900, a company named Zeppelin in Germany, which is still in existence, by the way, by that time they had perfected the design of airships and they can be considered to be the pioneers in the LTA aviation industry. In 1901, they came up with the first airship under their stable called as the LZ-1, the Zeppelin LZ-1, which you can see on the bottom left of your screen. And then 25, 26 years later, they created this very sleek and large airship called as the Graf Zeppelin. In one way, we can say that the Graf Zeppelin and the airships around that time, they were the best possible airships available in the technological era at that time. Okay. But Zeppelin used hydrogen-filled airships. And that is the reason. The reason for that is that helium was safe but in short supply. And several countries like the UK, the USA, the France, they discovered to their horror that hydrogen airships suffered from accidents. You can see the list of accidents, which is not complete. So while USA, UK, and France had a serious issue with the airships, Germany was flawless. Their record with hydrogen filled airships was absolutely flawless. And they were able to operate safely many airships. And the culmination of their design was the famous airship called Hindenburg. This airship, people may not remember, it has done 10 plus successful transatlantic trips way back in 1936. This was an airship which was funded by the Nazi Party, and at that time it was considered to be the fastest aerial platform available. You can call it as the Concorde of the 1930s because the best and the most luxurious transportation system available till that time was something like the Titanic, which would take 7 more days or 7 plus days to cover the transatlantic distance. Whereas the Zeppelin, the Hindenburg could cover that distance in half the time, nearly 3 to 4 days. The picture on the right shows you how big and how large Zeppelin was. You can see that there are some people standing below the airship. They are looking like ants to you. Okay, so that gives you an idea about the dimension of the Hindenburg. Now, Hindenburg was a marvelous design. It was a rigid airship, which means it had a rigid exterior, and inside that there were 16 large gas cells containing hydrogen. These cells were built with thin plastic film because the only job they had was to contain the gas. The entire load was to be taken up by the internal structure as shown in the bottom right. So you had a longitudinal members with vertical supports, and you had these uh, you know frames all along the length. Between the frames there were these 16 gas bags, and the frames were connected to each other by bracing wire made up of steel. So that is not shown in this particular sketch, but just imagine all these corner points that you see in the screen on the bottom right. Imagine that there are steel wires crisscrossing and providing the rigidity to the structure. The engines of this airship were mounted outside the airship externally. Okay. This was the beautiful structure of the Hindenburg. The airship skin was using a cotton, which is the linen material, and it was coated with a new chemical at that time called as cellulose acetate butyrate. Plus, there was an aluminium coating on top of it. The purpose of this aluminium coating and the cellulose was to, so the cellulose was protecting the gas bag from the sun, and the aluminium coating was making it waterproof. Now, little did they realize that what they are coating and what they are making now is almost something which is incendiary, as we shall discuss little bit later. Now, the Hindenburg, let us look at the fatal flight of Hindenburg, which was from Frankfurt in Germany to New Jersey in the US. In this flight, there were 97 people on board. Out of those 97 people, 36 people were passengers and the remaining were crew members. Notice that the number of crew members is far, far more than the number of passengers. When you have a large system like Hindenburg, you require lots of crew members to handle various aspects. It was a 3.5 day journey, and during this journey, there was a constant headwind or wind coming against the motion. Because of the headwind, there were delays, the speed was reduced, and when the airship was approaching the Naval Air Station at Lakehurst, it attempted to do what is called as a flying moor landing. In a flying moor landing, you basically aim to attach yourself to a moor or a huge mast as shown in the bottom right figure, and then you lower the airship and release some ladders and allow people to step out. Okay. Now, they encountered very bad weather, which became worse as they were approached to land. Let's have a look at the timeline of events that took place on that fatal day. The airship approached the landing station at 7 p.m., but because of certain winds, it wasn't able to properly align with the masts. So therefore, it had no option but to circle around and come back and attempt the landing again. So as it circled around, being a very bulky airship, it took some time. The radius was not very small. The bad weather intensified further as they were approaching to land. And when they were coming towards the when they were coming towards the mooring mast, again the wind changed direction. So the pilot also observed that the airship is leaning towards the rear. That means the rear is becoming heavy. So what they did is they dumped water from the front portion. Okay. They dumped water from the rear portion to reduce the weight of the rear side so that the rear goes up. And they also dumped some hydrogen from the front. Okay. So with that, the nose would go down. As they came towards the mooring mast at 7:21, that means 21 minutes later, the handling lines were released, which touched the ground, and they were being grabbed by the ground crew. 4 minutes later, a big explosion took place and the Hindenburg was burnt. Okay. So after the accident took place, it was observed by eyewitnesses that the explosion was seen between gas cell number 4 and gas cell number 5. Counting from the rear, you go to the gap between cell number 4 and 5. That is where the explosion took place. Now, the aftermath of this particular accident raised three key questions. First is, how did the explosion start? Second thing is, after explosion, the envelope caught fire. Why did the fire spread so fast? And the third, more important question is, could this accident have been avoided? In every accident, we are concerned about how to make things safer so that it doesn't happen again. So the first question is, how did the explosion start? Let's have a look at this particular question. So there were many possible theories. One theory was there any bomb blast or sabotage? This particular angle was thoroughly investigated by the CIA. Nothing was found, so it was ruled out. Then there was another thought Was there a fuel leak because of which the fuel caught fire? After all, 88,000 liters of diesel was stored in the fuel tanks at the airship bottom. Okay. However, diesel does not catch fire very quickly. It requires a temperature of 65 degrees centigrade to catch fire. So even if there was a fuel leak, how did it reach a temperature of 65 degrees to catch fire? The other way is the engines are mounted outside the structure and they are constantly being cooled by the ambient wind. So there is no way that you could heat up the diesel. The final nail in the coffin of this theory is that the fire began from the top side, back side, not near the engines. So therefore, this also was ruled out. Now, then there are other possible theories. One theory is that the hydrogen has combusted, but for it to combust, it has to escape and mix with air to become flammable, because by itself hydrogen is not flammable in the sense it doesn't catch fire unless there is some kind of a flame available to it and oxygen. Now, this is where investigation revealed that there was some kind of a fluttering observed from the top of the envelope surface just before the fire, because this airship was very much attractive for many people. So, as it came into land, lots of people were observing it or looking for it from various angles. Some eyewitnesses observed that there was some kind of a fluttering on top of the envelope before it caught fire. So then somebody came up with the idea that, oh, maybe there was a hydrogen leak and the leaking hydrogen was causing this fluttering on top. Now, so the hydrogen cannot leak in such a large amount from the gas cells because they are made up of plastic which is sandwiched with two layers of cotton. It is unlikely that this particular material which holds hydrogen would by itself create any leakage. So then the other theory is that there was a rupture of any of the gas cells, and that rupture led to the leak of the hydrogen gas, which then began bubbling out from the upper envelope surface. So now the question is, how did the gas cells rupture? So the theory is that there are these bracing wires which connect the elements of the frame. These are thousands of cables which uphold the structure. They were made up of steel which was almost 3 millimeters thick. And because of that, there was a high structural stress introduced in these cables. In the past, also, people have recorded in the maintenance records that these cables have broken. So there is a hypothesis. It says that for some reason, there was stress on the bracing wires more than what they can withstand, because of which the bracing wires snapped. And as the wires snapped, there was a whiplash, and that whiplash would rupture the gas cell. So again, the question is, why would the bracing wire break and why would there be a whiplash effect? So it was seen that in the attempt to come back and land at the mooring mast, the airship underwent sharp left and sharp right turn, something for which this airship was not designed. It wasn't designed for such sharp left and sharp right turns, which cause a lot of stress. So the theory is that the pilot had to undergo sharp left and sharp right turns so that it can align with the wind and dock with the mast safely. And because of that, there was enormous stress created. Now, why did the pilot make these turns? Because remember, they were late due to headwinds and bad weather. They were already late, and the airship had to go back in time to attend the King George VI coronation or return trip. If you follow the procedure and if you go for one more round, there will be more delay and more time pressure. So therefore, the pilots were forced to go for sharp left and sharp right turns. So the theory is that because of the sharp turn in a hurry to land, there was undue stress on the bracing wire, and because of the enormous load, the turning force exceeded the braking stress, so the bracing wire snapped. And where the bracing wire snapped, it led to a whiplash effect on the gas cells. Because of that, the gas cells ruptured, and when the gas cells ruptured, there was a hydrogen leak. Okay, so this theory explains two things. One, it explains the spluttering on the top of the envelope, because as the hydrogen is escaping from the envelope, it is mixing with hot air, and that can lead to fluttering of the air. And the second thing is, it was also observed that the airship became tail heavy before landing, which means the mass of the airship increased. That is because some hydrogen has escaped. So this corroborates the theory also. But then the question is, how did the explosion start? So here is the hypothesis. Because of sharp turns, there was stress. The sharp turns led to stress. The stress led to bracing. The turning force was much, much more than the gravitational force, or the braking stress of the steel wires. Because of that, it led to the hydrogen leakage. But how did the fire start? So then one theory is that this airship was coming in through thunderstorm and clouds. So during thunderstorms, there was a huge accumulated positive charge on the surface of the envelope. So now when the mooring lines were thrown and they were grounded, that means the whole charge was grounded. Okay, but it was grounded only from the airship. However, remember, there was a complication because there was rainy weather. So the airship consists of two entities. One entity is the metallic airframe, which is a good conductor of electricity. So potential is zero on earthing immediately. And the outer skin or cotton linen is a bad conductor. So there are some places where the skin is touching the airframe. At those places, the potential becomes zero immediately because the whole thing can be communicated. But then there are some areas where the skin is not touching the airframe. And in those areas, there was collection of water. Okay. Now, that does not allow you to lose the charge. So, the places where the skin was touching the airframe, because the airship was grounded, the whole structure was also grounded. So, all the charge vanished or was transmitted from the area touching the airship and also the area or the portion which is outside the envelope. But inside the envelope, there are certain areas on the envelope, where there is a puddle of water. That puddle of water has got a positive charge, and that charge is not going away because there is no way to ground it. So there you have non-zero potential. Now, if you have non-zero potential near zero potential, the non-zero potential is because of the wet outer skin, and the zero potential is on the airframe. Then experiment showed that sparks are generated. So this is one plausible solution. So what is the hypothesis? That because of thunderstorms, the surface became charged with atomic particles. The mooring lines were dropped, which only earthed the frame of the airship. But there is an outframe which contains water puddles and outer covering. So there is a potential difference which generates a spark, and that spark mixes with the air and the hydrogen that is leaking from the envelope. This is why the accident took place. And then experiments were done to confirm this. But then there was also many failures found. Some experiments were conducted, but it was found that it doesn't happen exactly the way it is predicted. So the most widely accepted explanation for decades has been that there was a charge difference created, there was a current created because of the differential between the envelope and the gondola material. But they tried to save by saying, shall we just check this? But then we are missing something. Now comes an interesting observation. There was one retired professor of physics called Mark Heald. He was standing on a mountain far away from the airship on a small hill. And he saw something very interesting. He found blue flames near the top of the rudder before the envelope caught fire. These blue flames were actually what is called as St. Elmo's fire. So St. Elmo's fire basically is a luminous plasma which can be seen at the tips of all electrically charged particles. This is basically a coronal discharge from the leading edge surface to an atmosphere. The aim is to equalize the potential of the field. So the main question that we come up is, did the St. Elmo's fire ignite the leaking hydrogen? Is that the cause of the fire? So what is happening here? On the entire envelope of the airship, you have positive charge. When you connect it to the earth, the charge becomes zero at all the places which are along the cable and also which are not properly insulated. They want to open them to investigate properly. Okay. So is it possible to have St. Elmo's fire here? Yes, it is possible theoretically. So here is a demo of St. Elmo's fire practically. When you pass electrical current over the particles of a noble gas like helium or hydrogen, helium mainly, we notice that some kind of blue colored flames do get radiated out. So the question now is that the St. Elmo's fire is outside the airship, but we know that the explosion came from inside the airship and it came so fast. So there must be a quick way of generating this. So once again, just for our memory refreshment, the estimated location of the helium leak was between chamber 4 and 5. Is there any question anybody has? Well, what we have established is that there was a whiplash because of which there was a leak in the envelope, leak in the gas cells. Because of that, hydrogen was releasing and coming up from the top. Now they observed that there was a ventilation shaft between cell 4 and cell 5. And the fire was seen, the St. fire was seen on the fin tip. So theoretically, they did some kind of investigations in the laboratory and they found that it is possible to have the fire, but they did not hear any explosion. They did not hear any loud sound. I'm sorry, they heard a very loud sound in the real life, whereas when they do the experiment, they actually made a small Hindenburg scale model and they subjected that to fire. They found that it burns, but there is no explosion. There is no loud sound. Okay. So it was found that There is a loud sound coming because there is a pushing of the air. So when you have release of hydrogen and when it comes and combusts on the top, there is a back pressure which sends the whole gas down and that sends more hydrogen up. So now let's look at how did the fire spread so fast. So the outer covering was an incendiary because, as I mentioned, the dope used to coat it was from cellulose, acetate, butyrate, and aluminum powder. Okay. Now, when you have aluminum powder, that is Al, with ferrous oxide, Fe2O3, you get ferrous and Al2O3. Now, it was found that the Hindenburg, the entire airship, which was such a large one in size, it burnt in 34 seconds. So, what made the fire spread so fast? So, they did some tests by firing some electrical signals on the material which was simulated from the balsa findings of the Hindenburg, and they found that the fire spreads very slowly, very fast. So this theory immediately fails. So that means the fire spread because of only hydrogen, because hydrogen travels at 9 meters per second, which is consistent with the burning of the airship. So it was established that the fatal fire was caused because of combustion of hydrogen. But the problem is the color that you see in the screen is the yellow color. So if the flame is yellow in color, it cannot be hydrogen because hydrogen is supposed to have colorless flame. So then they found out that there was an orange flame, and it was surmised that the combustion of the skin gave the flame an orange color. Now, coming to the last part, in every accident, we are concerned about could this have been avoided? What could have been done by the pilots to avoid the accident? What could have been done by the engineers to avoid the accident? So, anybody in the audience would like to answer this question before we go ahead? Could Hindenburg disaster be avoidable? Remember, we are looking at a scenario near World War II. So, here is the answer. The crew was anxious to land fast to save time. Because of that, they underwent those two sharp turns, first to the left, then to the right, for which the airship is not designed. Ideally, as per the standard operating procedure or SOP, they are supposed to abort the landing and exist and wait for better weather to come. Because that is something the airships can do. They need not travel. They may remain stationary. They may fly sideways or backwards. So, after the accident, unfortunately, all Graf Zeppelin helium powered airships had to be grounded. It was thought that helium is permitted as an airship gas, but it is too expensive. Now, see the effect of the war. In World War II, the Nazi Germany cancelled the airship program, and the revenue that was being earned by the Germans was directed toward the war effort. So, the funding and the support for the airship program was completely killed and stopped. Okay. Now, what is the final aftermath of this accident? Hydrogen has never been used again for passenger airships. Because of this disaster, there was a rule made that you cannot use hydrogen when you are flying manned airships. And you can't negotiate that. Second thing is the whole accident took place because of atmospheric electrical activity. So better research is planned in this area. And also, weather was one of the primary reasons. So nowadays, a lot of effort is gone in predicting and analyzing the weather patterns so that we do not subject our aircraft or operating systems to any bad weather conditions. So with that, I come to the end of my presentation on Hindenburg. I would like to open up the floor for any questions if somebody has. Anybody has any questions? Now we have 5 people in the meeting. Meghna has also joined, apart from Anamitra and Namanuddin. So Meghna, I don't know at what stage you joined this meeting, but could you please tell me, were you able to see the entire presentation? And also,
Yes, sir.
Anamitra,
I
wouldn't
was
you take the
joined 5 minutes later.
5 minutes late? Okay. But you have seen the bulk of the presentation, so you would be able to appreciate. Okay. Now, do you have any questions regarding what I presented today? Or do you have any questions regarding the course that we are doing and anything that you would like me to clarify? Because this is an interaction session where you are supposed to take the lead. See, I have already said what I wanted to say. Now the floor is open to anybody else.
So I have one question actually.
Yes, please go ahead.
Sir, are there gas chambers like you mentioned in Hindenburg? Are those present in the airships these days?
See, those chambers are still present in the rigid airships. The purpose of gas bags in the rigid airship is to isolate in case one gas bag is leaking. We don't want the whole envelope to go empty. So it is good to have gas bags to compartmentalize the whole envelope into smaller envelope bags.
Sir, is permeability a factor for determining the perfect gas chamber?
100%. One of the prime design requirements for the material for the gas bags is the permeability of hydrogen or helium depending on which lifting gas is being used. It's the prime requirement. Other than that, the requirements are lightweight, easy to join, easily available, affordable.
Okay,
Because it
thank you,
doesn't
sir.
carry any load. It is not supposed to carry any load. It is just supposed to hold the helium, and that too under almost atmospheric pressure.
Got it, sir.
Okay. Any other point or any other question you would like to ask?
Sir, I have a doubt.
Yes, please.
Sir, actually about centralmost fire, right? You have explained that, but I am not well aware
Okay.
of that.
It is called Saint Elmo's fire. Basically, what happens is whenever you have any electrically charged uh, components which have edges, you get what is called as a corona discharge. That corona discharge can result in some sparks, and those that is called as Saint Elmo's fire. It is just a name. It's just a name. Saint Elmo's fire basically means the corona discharge which takes place at the tips of an electrically charged body.
Sir,
So
that can
when you
be
are flying,
happened in a normal flight also, right? In HTA system, it's also
Yeah. If an HTS system also flies through thunderous and through electrically charged weather clouds, it will have St. Elmo's fire. But nowadays, whether it is airship or whether it is aircraft, we use what is called as electrostatic dischargers, correct?
Okay.
Which will convey all these surface charges and we will discharge them. But the problem is in case of LTS systems or in case of Hindenburg especially, there was a gas bag rupture because of which hydrogen was leaking and it bubbled out through the envelope and met this spark because of St. Elmo's fire, and there was atmospheric oxygen available. So that led to fire. But when it led to fire, actually the the whole envelope was covered with a material, cotton, which was doped with aluminum and this butyl acetate. And because of that, the envelope caught fire and the flame was traveling very fast because it is orange in color. And the hydrogen also then, combusted.
Okay, sir.
So now, if you look at modern airships, first of all, we don't coat them with these kind of dangerous chemicals. Secondly, we are nowadays mostly using materials which are much better in their gas retention properties. And if you take care not to load the structure in such a way that there can be whiplashes and rupture, there will be no leakage of hydrogen gas. Accidents do take place because in the beginning of the airship technology, people were not aware of these kind of effects. And because of stressing of the envelope due to the turns, it has led to the rupture. And the presence of clouds led to charge on the airship. So it's a double whammy. And because of that, there was this explosion and fire. Okay, so if there are no more questions, Naman, would you like to add if you want to convey anything in this session?
No, sir, I don't have anything. But last time we have shown one tutorial for ITDA wala aerostate. So
Yes.
we have asked them to solve it and submit it through forum.
Yeah,
But I
it is up
didn't
to
receive
them.
any. Yeah,
It's
but I
okay.
didn't receive any
See,
entry.
no problem. Naman, see, our job is to basically provide material and provide information to the students. It is up to them to use it or not to use it. Okay, because
Yes.
this is a self-learning course. We are not proactively teaching them like we do in the classroom. They have decided to take this course to learn on their own. So it is completely up to them. If they wish
Yes.
to apply their knowledge and do the calculations, they will be
Hmm.
able to learn more and enjoy the whole process. It's completely up to them.
Sure. That's only. And about the final exam preparation, we will be covering in third live session.
Correct. What is the date of that particular interaction session?
We will announce it through the forum. I think 17th April, if I am not
It
wrong.
will be somewhere in April. Okay.
Yes, sir.
All right. Okay. So with that, I would like to then stop the meeting. I would like to leave. Thank you so much for
Thank you,
being
sir.
present. And we will upload this particular presentation with the information regarding where you can watch some videos that explain whatever I have shown. Okay. Thanks a lot. Bye bye.
Thank you, sir.